Hello students, in this lecture video I am going to explain you about what you mean by composite wall and fins and how the temperature distribution takes place inside the composite wall and the fins. Okay, so these two are very important for the point of examination, and definitely they may ask you one numerical problem on either composite wall or fin. Okay, with the help of some formulas we are going to calculate the temperature distribution in the composite wall and fins. Okay, along with that we will discuss about some boundary condition. Okay, if you want to solve any numerical problems on this heat transfer means we require a boundary condition. Okay, without boundary condition we cannot solve the heat transfer problem. Okay, that also we will discuss in this lecture video. Okay, so this is syllabus. Okay, first one is the heat transfer through composite wall. Okay, so let me understand what you mean by composite wall. Okay, so composite wall nothing but what? It is a wall made up of a number of material. Okay, here it is widely used in the cold places to insulate the building from the cold outside surrounding. Okay, so that is the main purpose to use the composite wall. Okay, so composite, as the name indicate, composite means it is the wall which is made up of number of element or material, okay, bonding together which form a wall, okay, or a plane, that is called as composite wall. Okay, so it is typically consist of what? Insulating material packed inside the wall. Okay, the insulating material is usually in a two layers or it is more than two layers. Okay, so by using this we are going to save from the cold outside from the surrounding of any building. Okay, so what is a composite wall in heat transfer? Okay, that is a normal definition. So composite wall in the what is the it is used in the heat transfer because it compresses a number of layers of different material with a different properties and thickness. Okay, it will varies the number of areas, that is the thickness, width, breadth. Okay, such as include a number of what? A series of parallel thermal resistance arising from the different layer of the metal. Okay, each wall have some different characteristics. Suppose the wall which is made up of three layers means each layer having a different characteristics. Okay, different thermal conductivity. Okay, so those, that is what these three elements are perform different function. Okay, while using in heat transfer problem. Okay, so where our composite walls are used in the present day. Okay, some they are used in restriction of the construction of the projects such as a shopping mall. Okay, so while if you want to partiate the shopping mall, there we are going to use the composite wall. Okay, secondary renovation of the partition. Okay, if any building is there, if you want to renew that home, then we are going to use this composite wall. Okay, and it is also used to in the project to reduce the wall load, that is ultra high walls, light steel houses. Okay, steel structural prefabricated houses, all these are the main measure used in the composite wall. Okay, so just to understand that composite wall nothing but what? It is a made up of a number of layers of different material. Okay, each layer which has a different properties that will perform, which will make protect the buildings or what, the cold from the surrounding. Okay, so that is what the composite wall. Okay, so look at this. This is the heat transfer through a composite wall. Okay, this diagram indicate that. Let us, this is a composite wall. Okay, so two layer, so this is one layer, this is one layer, and this area is different, this area is different, and this is thermal conductivity is different, this thermal conductivity is different. Okay, so this is a composite wall. Like this will be there, we have to solve the numerical problems on this. Okay, how temperature going to distribute from T1 to this end surface. Okay, so you need to calculate T2, T3, they may give one boundary condition here. Okay, so that is initial surface T is equal to T naught, they may give in the question T naught, that is initial temperature is equal to 40 degrees centigrade, like that. Okay, from this to this outside, how it is coming, that you need to calculate by doing what calculation part. Okay, so this is element number 1. So if you draw the free body diagram of this, okay, so look at this, this is node number 1, this is node number 2, this is node number 3. Okay, so this is node number 1, node number 2, node number 3. Okay, so instead of displacement, here we are going to denote the nodal temperature as T1, T2, T3. Okay, so that is T1, T2, T3. So here there are 2 degree of freedom they given, that is the 2 boundary condition they are given. So that is initial boundary condition T is equal to T naught, some the value given. So here heat convection, due to convection also they given. Okay, so you need to calculate the temperature distribution. Okay, area for this is the element is different, this element is different. Okay, so here element number 1, element number 2. Okay, so heat transferred inside the block or wall, that is denoted by Q in and Q out. Okay, that is the heat, the Q stands for rate of heat flow. Okay, Q out, Q in. Okay, so this H is called as, denoted as a convection, and T infinity, here the T infinity is called as a ambient temperature. Okay, so here in this wall they given 2 boundary condition. Okay, depending upon that you need to calculate the heat transfer coming out and temperature distribution along the inside the wall, that is T2, T3. Okay, so this is the complete description about the what heat transfer through a composite wall. Just I'm okay, tell about this one. Okay, Next, second one, so heat transfer through fin. Okay, so in present day fins are used almost all the area. Okay, the fin nothing but it is an extended surface. Okay, if you want to use the main benefit of using these fins are we can increase the rate heat transfer from the one place to another place, that is the near surrounding. Okay, that is called as fin. Okay, so fins are the extended surface from an object or surface or a body to increase the rate of heat transfer rate. Okay, to increase the rate of heat transfer rate between the surface of and the surrounding fluid by increasing the heat surface area. Okay, so if you increase the fin, that surface area, you can transfer the more heat transfer. Okay, that is the main use of this fin. Okay, so this is a rectangular uniform fin will be there. So this is the length, so this is the width, this is a thin film. Okay, so here they are given extended, okay, surface, so that we can transfer the heat very fast from one place to another place. Okay, so many different types of things are they are used in the present day. Look at this. Okay, so this is a thin they are using in the rectangular block. This is a motor. Okay, so this is what here they are, these are called as a fin. Okay, so this is also fin, this is also fin. Okay, so this is also fin. Okay, to increase the larger area. Okay, these are the different types of fins which are going to use in the in the while doing the component. Okay, so because of this fins we are going to increase the rate transfer rate around the surrounding or around the material. Okay, so that is the main benefit for using this fin element. Okay, and numerical problems, so we are having the on this topic, that is fin chapter. Okay, that is what the fin. Okay, so look at this. Okay, straight or uniform. Okay, it is also called as a straight fin or uniform fin or a thin fin. Okay, so look at this example for motorcycle fin extended from the outer surface of the engine to dissipate the more heat by the convection. Okay, so if you take the motorcycle, okay, motorcycle fin, that can be we are going to extend up to the outer surface. Okay, from the outer surface we are going to extend. It is because what to dissipate the more amount of heat by the convection process. Okay, convection nothing but what I already told you, convection nothing but what the heat transfer takes place from one place to another place. Okay, but it is not in contact, that is called as a convection process. Okay, already I explained in the lecture video, that previous lecture video, that is number 1. Okay, so look at this is a uniform or straight fin. Okay, so if you take surface small amount of this area particular, that is called a dx. Okay, so here read, if you extend the surface area, we can transfer the heat from one place to another place very smoothly. Okay, very fast. Okay, so that is what this figure shows, that this is what the heat dissipation. Okay, this is the heat causes. Okay, so look at this, the same strip here taken. So okay, this is one end is fixed. Okay, this is another end, this is a rectangular block will be there, this is the length will be there. So here if you increase the air surface area, that with the help of fin you can transfer the rate of heat transfer from one place to another place very fastly. Okay, so this is what the fin. Okay, so while solving the problem, this equation is required. These two are called as a governing differential equation, that is one day heat transfer. Okay, that is kx nothing but what the thermal conductivity, so d square dt by dx square plus q rate of heat flow. Okay, so this is a h nothing but the convection, p nothing but the perimeter. Okay, m stands for area, T minus T infinity. T stands for the surface temperature and T infinity the ambient temperature. Okay, so this equation is helpful for to calculate the rate of flow inside the that element or the given material element component. Okay, so in the fin problems, no internal heat generation takes place. So consider q is equal to 0, then this equation reduced to like this. Okay, so this equation you are going to use to solve the here the thermal conductivity, that is what the rate of flow of here in the no internal heat generation, then q is equal, if you q equal to become this equation you are going to use to calculate what the given value. Okay, so these two are called as governing equation of the fin component. Okay, fin element, you have to remember these two. Okay, so this is about the fin and the fin and this one more the composite wall. Okay, so both are very very important for the point of examination. They may ask you numerical problems on composite or thin. Okay, if you solve 2-3 numerical problems, means you will understand how the temperature distribution takes place from one end to another end. Okay, so coming to the second topic in this lecture video, that is boundary condition. Okay, so boundary condition plays a major role in to solve the heat transfer problem. Okay, in the heat transfer problem, almost in all the problem they may give only minimum 2 degree of freedom, that is what minimum 2 boundary condition. Okay, if they given 2 boundary condition, means you can solve the problem easily. Okay, so normally here we are going to use the 3 different types of the boundary condition. One is the specified temperature boundary condition, insulated boundary condition, that is they will specify the initial temperature, specify the heat flux boundary condition, that is they may give the heat flux. Okay, one more is the convection boundary condition, that is what we studied in the first one, that is the first lecture video. Okay, so this is these two we will study about this. Okay, specified temperature boundary condition, that is, so this is a element. Okay, so this is what First one is specified temperature boundary condition. Okay, so this is one element, this is the one wall will be there or element. Okay, so this is done along the x and y, so this is length is L. So here they will specify this boundary condition. Okay, so T naught, that is initial temperature they may give in the question. T naught is equal to some value, so this end is called as the inner surface, this surface is called as the outer surface. This is due to the convection. Okay, so once here if you transfer the temperature from this to this, we need to calculate this. Okay, so from this the boundary conditions are what? At x is equal to 0, let us assume this is a x. Okay, x, this is, okay, so this is node number 1, this is node number 2. Okay, so the boundary condition are at x is equal to 0, T is equal to T naught, these are the specified temperature they will mention. At x is equal to L, so here at x is equal to L, Q is equal to this, the rate of transfer, that is a H naught, T L minus T infinity. Okay, so this we are going to use the equation. Okay, that is the specified temperature and minus T infinity. Okay, so this is T1 you are going to solve in the problem. Okay, so this boundary condition we are going to use when the specified temperature boundary condition insulated in the given problem. Okay, you have to remember this. Okay, coming to the second, the specified heat flux boundary condition. Okay, so here completely one end is completely insulated, that is Q is equal to 0. This is one type of the boundary condition. Again here they given one more boundary condition, that is heat transfer due to convection. Okay, so again this is beginning surface is called as inner surface, the end surface is called as outer surface. Okay, so again here what are the boundary condition? Nothing but at x is equal to 0, Q naught is equal to 0, because it is completely insulated, nothing will be heat transfer takes place here. Okay, so completely insulated, so Q naught is equal to 0. Okay, at x is equal to L, Q is equal to same H naught T, that is the initial surface temperature minus ambient temperature. Okay, so that is specified heat flux, where Q naught stands for specified heat flux on the boundary condition. Okay, these two boundary conditions they must give in the specified heat flux boundary condition. Okay, so here Q naught is going to consider positive when if the heat is flow out of the body. Okay, when the heat is going out of the body, then we are going to consider as positive value. If heat is flowing into the body, means we are going to take the value of Q naught is equal to negative. Okay, so this you have to remember, this is called as a note number 1. Okay, while solving problem this note is very important. Okay, so coming to the third, convection boundary condition, same what we studied in the lecture video 1. So that is the convection boundary condition, also known as the Newton boundary condition, corresponding to the existence of the convection, heating or cooling at the surface, and it is obtained from the surface energy balance equation. Okay, so what the energy balance equation that we will that condition we are going to satisfy for the given condition. Okay, so convection boundary condition, it is probably the most common boundary condition encountered in practice, since the most heat transfer surface are exposed to a convective environment at specified parameter. Okay, so that is in the convection boundary condition, that energy equation, balance equation should satisfy. Okay, that we need to recall this in this. Okay, that is what the convection boundary condition. Okay, every problem they may give convection boundary condition almost in the this model 4. Okay, so these are the three different types of boundary conditions which are going to use while solving the problem. Okay, so again some another this will be there. This is also how we are going to use formula for 1D heat conduction with free end convection. Okay, so this is another topic. Okay, look at this, is completely one end is completely fixed, the another one is free end will be there. Okay, free end due to convection is there, so that time we are going to use this formula. Okay, so look at this, observe the diagram this. Okay, so K stands for thermal conductivity, this is T1 T2, node number 1, node number 2, ambient temperature. Okay, so the heat due to convection, that is free end. Okay, so if this type of the diagram is given, means you can use the formula to calculate what the given given temperature. Okay, so this formula you are going to use AK by L 1 minus 1 minus 1 1 plus HA 0 0 0 1 T1 T2, which is equal to AH T naught 0 minus 1. Okay, why this 0 0 1? Because at the last element we are going to have the this heat transfer is exposing to the surrounding. Okay, so that we are going to write here. Okay, so where A stands for the area, K stands for the thermal conductivity, L stands for the length of element, H is the heat due to convection, A stands for the area, T1 T2 are the nodal temperature, T naught T infinity nothing but the ambient temperature. Okay, so here some problem they in the area they may not give. Okay, so if in such a case you are going to assume area is equal to 1 meter square or 1 mm square. Okay, depending on the given. Okay, so especially in this model they may not give the area, you can assume that area is equal to 1 meter square in the heat transfer problem. Okay, so coming to the second boundary condition, that is heat conduction with convection and internal heat generation. Okay, so this is one end is completely fixed, at the node number 2 is also completely fixed. Okay, if you transfer the heat, okay, if you give the heat, means here internal internal heat generation will takes place, that is heat flux, okay, that is denoted by q dash, okay, that is heat generation, okay. So during such case, such type of the problem, you are going to use this formula, okay. So that is ak by l 1 minus 1 minus 1 1 plus hpl by 6 2 1 1 2 q, which is equal to q dash al plus ht infinity pl by 2 1 1, okay. So this is the equation you are going to use when the internal heat generation problem, okay. If internal heat generation takes place means you are going to use this formula, okay. So where a stands for the area, k stands for the thermal conductivity, l for what, the length, h is the heat due to convection, p nothing but here perimeter, okay, perimeter of the given rectangular block or whatever that given element, okay. So l is the length, again q dash nothing but the heat generation in the given block or given element, okay. So this what h, okay, so remaining same, okay, I also dictated here, okay. So this is about what the composite wall and fin and what are the different types of boundary condition you are going to use while solving the problem, okay. So this we have to remember all the boundary condition, okay. This is most important lecture video, this is one, okay. Without boundary condition you cannot solve the numerical problems one, okay. So I hope you understand these two topic, okay. Thank you.